An atom is the smallest possible particle of an element and is one of the most intriguing theories in science. In today's lesson, we're going to take a look at the atomic structure and see how it develops over time. First of all, let's learn about the development of atomic structure. And basically around 400 BC, the early Greek philosophers argued that all matter could be subdivided into tiny, indivisible particles called atoms, which means cannot be cut or indivisible. And Democritus went even further. He stated that atoms have different sizes, are in constant motion, and are separated by empty spaces. And later on, in the 17th century, Dalton proposed that atoms are solid spheres like billiard balls, and he stated that all matter is made of tiny, indivisible particles called atoms, and all atoms of an element are identical, and atoms of different elements are therefore different. Atoms are rearranged to form new substances in chemical reactions. And in the year of 1897, the guy Thomson discovered electrons, and he found that an electron is a negatively charged, extremely small part of an atom. A new model of the atom now included electrons spaced evenly in a positively charged sphere, and this is also known as the plum pudding model. And here's a picture of plum pudding. If you don't know what it is, it's a famous snack in England, I believe. And the fruit part basically represents the electrons. In the year of 1909, Rutherford discovered the existence of nucleus. And 10 years later, so that was around 1920, Rutherford proposed that the nucleus is made up of positively charged particles, each one called a proton. And he also suggested that the nucleus is surrounded by mostly empty space occupied by electrons. And the model of an atom is known as the nuclear model. And these models set the stage for the later development of Bohr's model, which introduced fixed electron orbits, as well as the quantum mechanical model, which gives a more complex view or perspective of electron behavior. In 1913, Bohr stated that electrons orbit the nucleus of the atom in definite energy levels. And Bohr had again revised the model of the atom. His revision is called the planetary model. And in the planetary model, just like planets, electrons only exist in certain allowed orbits. And each orbit has a specific quantity of energy associated with it. And as a result, electron orbits are sometimes called the energy levels. And in this diagram, the red ball in the middle is called the nucleus, and the blue dots orbiting around the nucleus are considered the electrons. And in 1932, the guy Chadwick discovered the neutron. And as you may or may not know that, a neutron has no charge, so it is neither positive nor negative. But in today's lesson, I'm not going to expand on protons, neutrons, or electrons, because you guys should have learned them in grade 10. We combine ideas from the work of Dalton, Thomson, Rutherford, Chadwick, and Bohr to draw a model of the atom, and this is called a Bohr-Rutherford diagram. And we can use Bohr-Rutherford diagrams to show the number of each type of subatomic particle in a specific atom, and to represent the arrangement of electrons around the nucleus. For example, in this diagram, the first number shows the number of protons, and the number below it indicates the number of electrons. And furthermore, most chemical reactions only involve electrons in the outermost energy level. And the outermost energy level is also known as the valence shell. And the electrons in the valence shell are called valence electrons. Here's a brief summary of subatomic particles in an atom in terms of their symbol, location in the atom, charge, and approximate mass. And we're going to come back to their approximate mass at the end of the lesson. Now let's talk about the atomic number. The number of protons in an atom of a specific element is known as the atomic number, and they increase across a period by 1. and the symbol Z is often used to represent the atomic number. And all atoms of the same element have the same atomic number. For example, a carbon atom always has 6 protons. A magnesium atom always has 12 protons. And an atom of argon always has 18 protons. And the atomic number is usually written in the top left corner of an element cell on the periodic table. The mass number for an atom is the sum of all the particles in the nucleus. And we do not consider the electron's mass because they are too light. And actually, the mass of the electron is only 9.11 times 10 to the power of negative 31 kilogram. So that is too light to be considered. And the number of protons plus the number of neutrons is equal to the mass number. And take chlorine as an example. You can get the number of neutrons by subtracting atomic mass by atomic number. So that would be 35 minus 17, which gives you 18. So 18 is the number of neutrons. If you're wondering why the atomic number for chlorine is a decimal number, well, that actually involves the idea of isotope, which we're going to discuss in our future lessons. Given that atoms are extremely small, the scientists agreed to use the atomic mass unit to represent the mass of an atom. The atomic mass unit is defined as 1/12 of the mass of a carbon-12 atom. And after meticulous experiments and calculations, scientists have determined that one atomic mass unit equals 1.66 times 10 to the power of negative 27 kilogram. And for example, the mass for a proton and the mass for a neutron are both one atomic mass unit, while the mass for an electron is only about 0.00054 AMU, or atomic mass unit. Lastly, I've got some questions for you. And that's about it. Thank you for watching, and I'll see you in the next episode.